Welcome back, everyone. So in this lesson, we're going to talk about finding the inverse of exponential and logarithmic functions. Just to kind of briefly recap and start off, so what an inverse technically is we're going to take our exponential function that we have here, and then with the known points that we do have on our graph, what we're going to do is we're going to take the coordinates and we're just going to flip them. So when I flip them, then we're going to result in these three following points. And then also notice our horizontal asymptote is actually going to flip and become a vertical asymptote when we do the inverse. So when I take the inverse of an exponential function, that's going to yield us a logarithmic function. So I already kind of did the composition down here just to kind of show you. So what's happening over here is when I plug in and do the composition of f of g of x, I'm going to plug in log base 3 of x into f of x for my x value. So that's going to give us 3 raised to the log base 3 of x. And then when I convert to logarithmic form, since we're already in exponential form, that's going to give us log base 3 of n equals log base 3 of x. And then when the base values of these logs are equal, I'm going to take the arguments and then set them equal. So when I do my composition, that's going to give us a positive 1x, which is what we want. So when I do the composition the other way, and when I do g of f of x, I'm going to take my exponential and plug it into my logarithmic equation. So that's going to give us log base 3 of 3 raised to the x. Then we're going to do power property and move the exponent as a coefficient. So then we're going to have to evaluate and find log base 3 of 3, which when we evaluate, that's what you see over here. That's going to give us a value of 1. So we're just left with a positive 1x. So when we do our composition, that tells us that both 3 raised to the x and log base 3 of x are going to be inverse functions of each other. So the focus is we're just going to be finding the inverse of the given equation. So starting off, if I have a log equation that's given to me and I want to find the inverse, that means our inverse is likely going to be an exponential equation and vice versa. So what I want to start off with is I'm going to rewrite f of x as y equals. So we're going to have y equals log base 3 of x, which is kind of a bad example to start with considering we already found the inverse up here, or we know the inverse is going to be 3 raised to the x. So what's going to happen is when I do the inverse, I'm going to flip the x and the y. So I'm going to rewrite this as x equals log base 3 of y. And then what's going to happen with inverses is we want to solve for our y value. So in order to solve for the y value and get it out of the argument, you're going to have to convert to exponential form. So I'm going to rewrite and do 3 raised to the x equals y. So that's going to give me 3 raised to the x equals y. So then I'm going to flip it. So we have y equals 3 raised to the x. So we could also write it, since we're doing inverse notation, we could also write it as the inverse of f of x is equal to 3 raised to the x, since we know that 3 to the x is going to be a function. Okay, so looking at the next one. So with, well, that's number 3. Oh yeah, duh. I thought we started on number 1. Anyways, so I'm going to start by rewriting as y equals, but I'm going to go ahead and do the inverse. So I'm going to rewrite it as x. So x equals log base 4 of y plus 10, and I'm going to solve for y. So I'm going to subtract 10 on both sides. So we've got x minus 10 equals log base 4 of y. So I'm ready to solve for the y value, so I want to get it out of the argument. So I'm going to do circle of life and rewrite it as 4 raised to the x minus 10, which is equal to y, and then we're going to flip it over. So y equals 4 raised to the x minus 10. Same idea. So I'm going to change this and do x equals. So x equals negative 4 times log base 6 of y. So first thing I want to do is, remember, we're trying to isolate the logarithmic value. Then we can convert. So I need to get rid of this negative 4 out the front. So I'm going to multiply both sides by a negative 1/4. Or you could divide both sides by negative 4, however you want to write it. Personally, I prefer the fractions, but that's just me. So this is going to give me a negative 1/4 x equals log base 6 of y. And then I'm going to rewrite. So when I convert, that's going to give us 6 raised to the negative 1/4 x equals y. And then, of course, flip it over. So y equals 6 raised to the negative 1/4 x. And then depending on answer choices or how we may want it written, we may want you to get rid of that negative exponent. So if we want you to get rid of that negative exponent, then you would need to write it as 1 over 6 raised to the 1/4 x. Or another potential solution or way that we could have you write it is going to be 1 over the 4th root of 6 to the x. So there's just a bunch of different ways that we could have you write it, but we'll see. So I would say try 5 and 6 on your own, and then we'll do those two. So with number 5, same idea. I'm going to do x equals 1/5 log base 5 of y plus 2. And then I'm going to get rid of that 1/5 out in the front, so I'm going to multiply both sides by 5. So that's going to give us 5x equals log base 5 of y plus 2. And now I'm ready to convert since I have my logarithmic expression isolated. So I'm going to do my conversion. So this is going to give us 5 raised to the 5x equals y plus 2. And then subtract the 2 over. So I'm going to be left with y equals 5 raised to the 5x minus 2. And then number 6. So I'm going to go ahead and rewrite it as x equals. So x equals log base 6 of negative 3. I'm actually going to go ahead and factor out that negative 3. So that'd be x minus 3 minus 7. Whoops, that should be my y value. There we go. All right, so now we're going to begin by isolating the logarithm, which means I need to get rid of this negative 7 here. So that means I need to add 7 on both sides. So x plus 7 is going to equal log base 6 of negative 3 parentheses y minus 3. And now I'm going to convert since the logarithm is isolated. So we're going to roundabout, switcheroo. So that's going to give me 6 raised to the x plus 7. It's going to equal negative 3 parentheses y minus 3. So the big reason before that I factored out the negative 3 is when I'm doing inverses, I find that going ahead and just splitting it out into its individual parts is going to be the easiest. So my recommendation is you actually treat these kind of like transformations. So if you have a b value that's not equal to 1, I would say try to factor it out if possible. So when I get down to this step, this is kind of why. So I'm going to get rid of this negative 3. So I'm going to multiply both sides by negative 1/3. That's a 3. I don't know why I struggle so much with 3s. So when I rewrite, so this will give me negative 1/3 times 6 raised to the x plus 7 equals y minus 3. And then last but not least, we're going to add the 3 over. So this one's going to have a lot of moving parts. So our inverse, we're going to get negative 1/3 times 6 raised to the x plus 7 plus 3. All right, so let's go ahead and move on. So now let's go ahead and do some exponential equations. So if I'm starting with an exponential equation, odds are what that means is we're going to end up with a logarithmic equation since that's the inverse. So same idea, I'm going to go ahead and just start by rewriting. So this will be x equals 6/5 times 2 raised to the y plus 1. And once again, of course, we're trying to get the y value by itself. So what I'm going to do is I want to get rid of this 6/5 first. So I'm going to multiply both sides by 5/6. I'm going to multiply by the reciprocal. So doing that, we're going to get 5/6 x equals 2 raised to the y plus 1. And now I can't get the same base on both sides. So when that happens, That tells me I just need to rewrite and convert it to logarithmic form. So I'm going to do circle of life. So when I do circle of life, we're going to have log base 2 of 5/6, and that's going to equal y plus 1. And then I'm going to subtract my 1 on both sides. So that's going to give us y equals log base 2 of 5/6 minus 1. Now, of course, be very careful. I forgot my variable. Whoops, I knew I was missing something. 5/6x. My bad. Okay, as I was saying. So make sure when you get your final answer here, you're not going to combine these two values because I'm only doing log base 2 of the 5/6x. It's more obvious now because now I have the x value, but just in case we have just a constant there, just make sure you don't combine them. All right, and then number 12, same idea. I'm going to go ahead and rewrite it and do x equals. So negative e raised. I'm going to write this as 1/2 y. Same thing. Okay, and then as said before, isolate your exponential or your log, whatever you're trying to solve for. So in this case, I get x plus 2, and that's going to equal negative e raised to the 1/2 y. I'm going to go ahead and get rid of the negative now. So you can multiply by -1 or you can divide by -1. It's really up to you. So I'm going to leave it as negative parentheses x plus 2 equals e raised to the 1/2 y. And then in order to get rid of the 1/2 exponent, I'm actually going to square both sides. Okay, so what's going to happen now is we're going to have, let's see, negative parentheses x plus 2. My brain stopped working for a split second. E raised to the y. There we go. So this is one way to do it. I'm kind of doing it in a more complicated way, but it all works. Okay, and then I'm ready to convert. So because I have e as a base, that means I need to use a natural log. So I'm going to have the natural log of negative of x plus 2 squared equals y, and then you're going to flip it over. Okay, and then what could happen potentially is your exponent up here, based on power rule, we could have you write it in the front, depending on answer choices. So even though what we have here is a legit solution, we could also expect you to write it as 2 natural log negative parentheses x plus 2. So that's another way that we could have you write it. So just keep that in mind. Okay, and then I would say you guys try 13 and 14, and then we will move on to the next. So once again, 13, so we're going to rewrite this as x equals 3 raised to a negative y plus 4. So there's no vertical transformations that I can get rid of, so the exponential value here is already isolated, so I'm just good to just go ahead and rewrite. So this will be log base 3 of x is going to equal the argument. So log base 3 of x is going to be equal to negative y plus 4. And then I'm going to subtract the 4 over. So I'm going to have a negative y is equal to log base 3, that's a 3, of x minus 4. And then I need to get rid of the negative with the y. So I multiply or divide both sides by -1. So that's going to give us a negative log base 3 of x plus 4. So this is one way that we could write it. I know typically mathematicians, we don't like starting an equation off with a negative. So we may also rewrite it as 4 minus log base 3 of x, but it's all the same. All right, then for the next one, so for 14, so hopefully you already did this one. So I'm going to go ahead and rewrite. So x equals 3 raised to the 2 raised to the y plus 4 minus 5. All right, and then what's going to happen? Add 5 on both sides, add 5 on both sides. So x plus 5 is going to equal 3 raised to the 2, or not raised, 3 times 2 raised to the y plus 4. There we go. Okay, and then I need to get rid of that 3, so I'm going to multiply both sides by a third. So that's going to leave us with 1/3, parentheses x plus 5, which is going to be equal to 2 raised to the y plus 4. And now I need to get the y value out of the exponent, so I'm going to convert. Okay, so this is going to be log base 2 of 1/3, parentheses x plus 5, and that's going to equal y plus 4. And then we're going to move that 4 over. So then your inverse here will be log base 2 of 1/3 times x plus 5, and then minus 4. Okay, I'm going to go back to 13 for a second. I feel like I messed something up. Now, I think I'm good, because I also have my answer key right here. I think I messed something up. But feel free to fast forward and skip this part if you need to. Sorry, y'all. So maybe I'll come back to it. If I make a mistake or find the mistake, then I'll write it in the comments. Okay, number 20. So I'm going to nope, I can't read. I'm going to let h of x equals 3 raised to the x plus 1 minus 2, and then we're going to let k of x equal the inverse of h of x. For what values of x does k of x equal 1? So what you're going to do is we're essentially looking to see where does the inverse equal 1. So the first thing that's going to happen is we need to find the inverse of h of x. So I'm going to start and go ahead and switch the x and y. So x equals 3 raised to the y plus 1 minus 2. So when I find the inverse, first we're going to add 2. So x plus 2 is equal to y raised to the y plus 1. Now, I can't get the same base on both sides, so I'm going to go ahead and convert, circle of life. So we're going to have log base 3 of x plus 2, and that's going to equal y plus 1. And then we're going to subtract 1 on both sides, so my inverse, which I'm going to go ahead and write it as inverse of h of x, I'm going to go ahead and write it as log base 3 of x plus 2 minus 1. And then I want to set the inverse equal to positive 1. So when I get my inverse here, so I'm going to have log base 3 of x plus 2 minus 1. Then we're going to set that equal to 1. So I'm going to find the x value, so I'm going to add the 1 on both sides. So we're going to have log base 3 of x plus 2 equals 2. And then I'm going to do circle of life so I can solve for the x value and get the x value out of the argument. So this will turn into 3 squared equals x plus 2. So that's going to be 9 equals x plus 2, which subtract 2 on both sides, which means we're going to have an x value of 7. Okay, and then next, now we're going to do, so the nope, I really cannot read today. So the exponential function h of x equals a to the x contains the points 2, 3, and 6, 27. You want to find the average rate of change of y equals log base a of x over the interval 3, 27. Now notice how the original function they give us is going to be a raised to the x, and then the function that they want us to find the average rate of change of is log base a of x. So notice how these bases are the same. So what that tells you is you need to know that exponentials and logarithmic equations are going to be inverses of each other. So this is saying find the inverse of a of x, then we're going to use the coordinates of the inverse to find the average rate of change. So what happens is we know h of x is equal to a to the x. Now based on this, I know that the inverse is going to be equal to log base a of x. So the given points that they have are going to be 2, 3, and also 6, 27. Now, just like what I showed you at the very beginning, when we switch the points of coordinates for inverses, it's the same principle that we're going to be using for this problem. So down here, when I find the inverse of these points, we're just going to flip the x and the y. So these points are going to turn into 3, 2 and 27, 6. So we're going to find the average rate of change of these points. So when I do that, we're going to have average rate of change. And I want to find the average rate of change over the interval 3 to 27. So this is going to be using the inverse. So I want the inverse of h of 27 minus the inverse of 3 over 27 minus 3. And when I plug in these values, we're going to have the result of 27, which is 6, minus the result of 3, which is 2. And that's going to be over 27 minus 3, which is going to give us 24. So 6 minus 2, which is going to give us 4 over 24. And then we simplify, so we have an average rate of change of 1/6.